All right, let's talk about a silent killer for modern businesses. It's that huge, terrifying gap between the moment a critical system fails and the moment someone, anyone, actually does something about it. Today, we're going to break down how to move away from that chaotic and middle-of-the-night firefighting and into a much smarter, automated way of keeping the lights on. Let's dive in.
So, let me ask you this. What happens when your super smart AI spots a critical problem, but it's 3 in the morning and your entire support team is fast asleep? Your systems are screaming that something's wrong, but no one's there to listen. This isn't just a thought experiment, by the way. It's the core of a real-world disaster we're about to dissect.
And that brings us to this case study from a company called Wooclap. It is a perfect, painful example of this exact problem. Okay, so look at the timeline. At 7:29 a.m. Singapore time, peak hours for their users, someone spots a major bug in the UI. Just 12 minutes later, the company's AI agent, nicknamed Wooston, sees it and acknowledges the event. So far, so good, right? But then, crickets, total radio silence. The first human doesn't even look at it until after 5 p.m., and the problem isn't actually fixed until almost 11:30 that night. That is a 16-hour failure, all while the system knew exactly what was wrong.
Now get this. For 10 solid hours, the system knew there was a problem. The AI had flagged it, but absolutely nothing happened. This gigantic delay is what we call the human-in-the-loop trap, and it shows a massive flaw in how so many global services are supported. So how do we stop this from ever happening again? Well, it all starts with actually understanding the signals your systems are sending you.
The very first step is learning how to filter out the noise. You know, in any complex system, there are thousands of things happening every single second. If you treat every tiny blip like it's a 5-alarm fire, your team is going to burn out from alert fatigue. They'll just start ignoring everything. The real secret is knowing which alerts are just background noise and which ones are the first sign of a catastrophe.
To do that, we need to get on the same page with a key definition. We're going to borrow from the ITIL framework, which is pretty much the gold standard playbook for running IT services. In ITIL, an event is just any significant change of state. A change to what? Well, to a service or something they call a configuration item, or CI. Now don't let the jargon scare you. A CI is just any piece of the puzzle, a server, a database, an application, you name it. So an event could be anything. A user logging in, a server's fan speed changing, a backup finishing. It's not good or bad, it's just a thing that happened.
And this is where it gets really important. We have to sort all those events into 3 buckets. First up, you've got your informational events. Think of these as routine diary entries. A user logged in, a backup completed. We log them, but we don't need to do anything. Then we have warning events. These are the yellow flags. CPU usage is creeping up to 85%, or disk space is getting low. They're telling you, hey, if you don't do something soon, things are going to break. This is your chance to be proactive. And finally, the big one, exception events. These mean failure. A server is down, someone's trying to hack an API, a customer promise, an SLA has been broken. These require immediate, drop everything and fix it now action.
The easiest way to think about this is like a traffic light for your systems. Informational events, that's your green light. Everything's healthy, business as usual. Warnings, that's the yellow light. Slow down, be cautious, there might be a problem up ahead. And exceptions, that is a hard red light. Stop, a failure has happened, and you need to take immediate action. This simple hierarchy is your best defense against alert fatigue. Before we move on, let's just lock this in because it is so important. Informational is noise you can log but safely ignore. Warning is a signal to get ahead of a problem before it happens. An exception is the house on fire that needs everyone's attention right now. Getting this right changes everything.
All right, so let's take this new knowledge and jump back to the Wooclap disaster. Now that we know about these different event types, we can pinpoint exactly where their process failed. That UI glitch wasn't just some informational blip. It was a critical exception. It was a red light. But their system just wasn't built to handle that red light without a human driver.
This quote from their analysis just hits the nail on the head. The AI, Wooston, actually did its job perfectly. It caught the event, it saw the failure, it processed it, it logged it. But the whole system fell apart because the AI had no power, no autonomy to either fix the problem or even just escalate it to a human who was actually awake. The technology worked, but the process built around that technology was completely broken. Now, to catch these events in the first place, systems generally use one of 2 techniques. First, there's active monitoring, which is also called polling. Think of this like that slightly anxious friend who texts you every 5 minutes, "You good? You okay? Everything all right?" A tool constantly pings a server to check its health. This is amazing for your absolute most critical services, where you can't afford a single second of downtime, but imagine doing that for thousands of servers. All that constant checking can swamp your network. You could basically launch an attack on yourself just by trying to see if you're okay. That's why we have the second technique, passive monitoring or alerting. With this, the system stays quiet unless something bad happens. A device only sends a message when a line is crossed, like CPU hitting 90%. For any big environment, this is just a much smarter, more efficient way to operate. You only raise the alarm when it's really necessary.
So if the AI detected the problem correctly, and the alert was technically sent, but the human response failed, how do we fix this? The answer is, you have to build a system that's truly resilient by automating the right response. It's not enough to just see the problem, you have to automatically start the solution.
And the lessons from the Wooclap failure give us a great playbook. 3 key solutions. First, tiered automation. This is simple. If a human doesn't grab a critical alert in, say, 20 minutes, the system automatically escalates it. It pages the on-call engineer. The machine takes the next step for you. Second, if you run a global service, you absolutely need a follow-the-sun support model. This means when the team in Europe logs off, responsibility gets handed to a team in North America or Asia that's just starting their day. No more time zone traps. And third, predictive thresholds. Instead of waiting for users to complain, you create smart alerts for patterns, like if the same error happens 5 times in a minute. That way, you catch the fire before it spreads.
This all leads us to what a modern, ideal operational flow should look like. ITIL calls it Data-Driven Orchestration, and it's a 4-step dance. First, you predict. Use data and analytics to see problems coming. Then, you catch. Detect the actual event with your monitoring tools. Third, you process. This is where you use our traffic light system to filter the noise and find the real emergencies. And finally, you notify. But notify doesn't just mean sending an email into the void. It means triggering an automated workflow or paging the exact right person or team that can actually fix the problem.
So far, we've been focused on events, all those little signals of change. We've talked about how to predict them, catch them, and process them. But what about that last step, notify? What actually happens when you've found a critical exception event and that automated notification goes out? Well, this is where we build the bridge to the next, much more serious phase in the ITIL lifecycle.
And here is the single most important rule that forms that bridge. A confirmed exception event, a red light, is what officially triggers an incident. You see, an event is just a piece of data, a change of state. An incident, on the other hand, is a formal declaration that the business is now being actively harmed.
So what is an incident? It's defined as any unplanned interruption to a service or a reduction in its quality. The second an incident is declared, the game changes. A new clock starts ticking, and the primary, #1 goal is to restore normal service as fast as humanly possible, to limit the damage. This kicks off a whole new set of procedures called incident management, which is all about one thing: rapid recovery.
Which brings us to a final, really important question you need to ask your own team. When things go wrong, are you truly solving the underlying problems? Or are you just getting really, really good at resuscitating the same incidents over and over again? The shift from blind reaction to data-driven orchestration is really a shift from being a paramedic who just keeps the patient alive to being a doctor who cures the disease. And that is the challenge and the goal of any modern operations team.